an unsettling night for me, but I'm going to try to do my best. Yeah, that mouse won't move anywhere. Um, why don't we try to get going here if we can? And what we'll do now is we'll start up our imaging program called SharpCap. And we're running the latest version of SharpCap, literally night before last. If I can just get the mouse to go over and choose the camera. Fortunately, I have a touch screen, so I'm hoping that'll mean we can at least use our fat fingers on the screen and try to at least get started. But this is not ideal. I'm here to tell you we can't do anything with the mouse yet. But now I'm tabbing because at least if I tab, I can get kind of over to the right place on the screen, right? So here we are in SharpCap. And you know what we're going to do is start up another instance of SharpCap. And in the second instance of SharpCap, we will open up the camera to a widescreen camera that we have set up on the scope. And we'll set it on about, I don't know, 2 seconds or something with a high gain. That's high enough. So that's pretty much the widescreen view. I think that bright thing you see over there to the right is the moon, and it is way bright tonight. Yeah, that is the moon. Then at the bottom, you can see the actual dew shield, the top of the telescope. And then all the way up there, let me see if I can get the mouse to, boy, it is not cooperating. Here's the Big Dipper, you see. Look, there's the handle, and there's the cup. And so it's pointing at the North Star right there. So that's Polaris. Let me get the live stream up on my phone and just make sure that we've got audio going. I can do that by turning up the audio. Yeah, so we've got audio for sure. So we'll keep this instance of SharpCap open that is letting us connect with the whole night sky. And you can see it's a beautiful night sky tonight, except the moon is kind of dominating there, huh? Let's go over to the camera that is kind of, it's the ZWO ASI 2600 MC Pro. This is the widescreen format camera that gives us actually, and it's hooked to the Rasa telescope. Let me see if I can get the Rasa telescope for you. Why can I not? Oh, there, you're seeing in the lower right-hand corner, huh? So the view of the telescope that we're seeing is through another camera. It's a WISE 3, and some of you all have come across these before. Ken, it's nice to have you here. Welcome. It's the WISE 3, WYZE, and it's a security camera. The other night when we were doing a live stream, our security camera kind of froze out, and sure enough, tonight would be the kind of night that would happen. In fact, we have, let me see if we can pull up the temperature out there on this screen up here. Nope, that's our USB control hub. Let's grab this one. Yeah, up in the upper right now, you ought to be able to see the temperature. I would put my mouse up there. Oh, there's the mouse moving a little bit. It looks like the temperature is 13. That's 13.8 degrees, and that's the real temperature. I don't know what the feels like temperature would be. It says the relative humidity is 74%, so it's calculated the dew point at 7.2 degrees Fahrenheit. You can see that the dew controller is popping on and off, and we can tell that by looking down here. I don't know if you can read that very fine, the voltage fluctuations there, but they are popping. The dew straps around the scope are popping on and off. So it is a cold night. 13 degrees real and probably lower than that with a feels like temperature. So why don't we come back here to sharp cap? Let's go ahead and lower those if I can. If I could just get my mouse to work again. Why don't we open up our planetarium program and we use Starry Night Pro for that. Actually, we're using now Starry Night Pro Plus, and it is a beautiful picture of the night sky. I'm gonna open up. Well, there, that mouse is playing tricks on me again. I'm gonna open up. I happen to use the touch screen. Open up a preferences file here, and let's go over and look north with the scope. And what we'll do now is we'll try to connect the telescope, and we'll just try this. Okay, it looks like it's connected. And then for right now, let's click this little button that says follow the scope. There you go. So now wherever the scope goes, the planetarium software should go. This is a new photorealistic horizon I've got set up here, and I really like it. It's a lot more true to the night sky here at Emerald Hills. That tree that you see there is really there, and you'll see as we spin around. There's Popotech down in Florida. Oh, it's cloudy tonight. Sorry to hear that, Popotech. And Ken, oh, you're on the Horsehead Nebula from Michigan. Oh, I bet it's cold up there as well. What's the temperature up there, Ken? There's a little delay there. So I'm going to call up the Messier list here. And if I remember right, the other night, boy, I would love to get my mouse back. Boy, it is just not. If you missed this, what I did is I cleaned the trackpad with some hand cleaner, and what a bad idea that was. It did not work out at all. I think we finished Messier 60. Oh, real feel about 9. Yikes, that is cold. I think we're ready for M61 over there on the right. And let's see if that's, let's see. Maybe if I get my slew to M61, if I can get the mouse to move. Man, this is not a good night for the mouse, is it? Simon, glad to have you here from hot Western Australia. Go ahead and rub it in. Frank, too cold for me too. Took the night off. I don't blame you. It is freezing out there, boy. When I came in, my fingers were just freezing off. Oh, this is going to be a good test. Looks like we're way low on the horizon. Oh, I mean super low. Look at that. It says M61 is not even visible. Huh. Wonder why. Oh, it showed up over there as 6 degrees. But I wonder if that means that our landscape, photorealistic landscape deal is too high. So let's hide the horizon. And there's M61. Maybe our photorealistic landscape is actually raised up too high. So why don't we kind of look and see what we're supposed to see. This is M61 is supposed to be a spiral galaxy. Look at that. Okay, so we're going to look on it about face on there. That'll be fun. Let's go back over to sharp cap in the 2600 then. Oh, yeah, look. I'm seeing some trees there. How about you? let's look at our, yeah, maybe in fact, for all I know, we're looking right into that building there. And by the way, that window that you see, wish I could get my mouse to work and I could show you. That window that you see right there, that's my window. I'm going to turn the lights off so you can see that's the office that I'm observing from. See the lights went off there in the picture? And there you see my power cord and my fiber optic cable strung across the grass to the office there. I'm set up in a different spot tonight. This is the night. This is a spot that I hope I'll be able to catch M30 at the end of the Messier Marathon. Yes, Simon is asking why we switched to Starry Night Pro Plus. You know what? I'm going to tell you that. Let me switch the slide back on. I wanted this really nice, beautiful, the stars that are there, and they're really nice in Starry Night Pro Plus. It gives you a real beautiful picture of the night sky, and it is like a photo of the night sky that's been all meshed together. I think, what did we say the other night? I looked this up. Was it 20,000 photos of the night sky that had all been meshed together? And it's a completely different world now than what it was to have those simulated stars in Starry Night Pro. So that's why we went with Starry Night Pro Plus. Okay, so this is at 7 degrees, but you can see here, you know what that is? That is my window that we're looking at, I think. we're looking at the building, so we're not going to be able to do M60. It is too low yet on the horizon. So that's M61. Let's try M63. It's supposed to be at 19 degrees. Let's see if we can do a little better with it. And while that's slewing, let's catch the telescope so you can see a live picture of that Rasa 11 slewing. You can see it's on an Ioptron tri-pier. Is that what they call that? And then the mount is the Ioptron CEM70G. And so there's the Rasa there. Let's see if we can do any better with M63. Let's go back over to our, first of all, yeah, we're looking a little bit higher now. Let's go back over to the 2600. Oh, yeah, this is looking more promising. So why don't we switch now? Boy, I wish I could get my mouse back, but it is not. It is not coming back. Let's go to the sequencer, and we'll go to start imaging. So that sequence that we've got set up, and what it does is it sets the exposure on 20 seconds and the gain on 100, and then it starts the live stacking. We'll go ahead and put in the target name here. This is M63, and we did focus just beforehand. Look at that moon, boy. We are certainly looking straight at the moon here, aren't we? While that's forming up, let's go back over here to the 178, and that is definitely the area of the sky that we're looking at, isn't it? Wow. Let's look at our planetarium software and kind of back off for a minute. See if we can find the moon here. Somebody help me find the moon. Where is the moon? I'm going to take the telescope off, follow scope, and oh, look at that. Starry Night Pro stopped. That's not very fun, is it? Let's start that back up, and let's get that moon. Let's find that moon. Moon. having to use the touch screen here. So it's going to bring us over. So there's the moon right there. Okay, now let's find, let me get rid of this sky because I think I've got the sky a little bit too high. Now let's find M63. So remember where that is. It's up there by, off to the right of Denebula. Now let's find M63. So we're off to the left, but not very far off to the left. Okay, so let's go back here and why don't we, boy, I wonder if I can use my touch screen. Yeah, I can change those. Fortunately, I can use my finger to change the live stacking because the mouse is worthless tonight. I'm gonna do an automatic color balance here. Boy, this is a trying times here with this mouse. Let's get this. Get our blue dialed down a little bit. Get this moon under control. You know what we should have done? Before we do this live stack, let's do a plate solve because this is our first target. And, man, how in the world do people live without a mouse? How is it possible? Without a mouse in the house. You have a setup similar to Mike Jerry, Ken says. That must mean you have concrete blocks glued together, and then you have a wedge and like a 6-inch on top of it, if I remember right. Yeah, we were 4 degrees off because this is our first target, and we did pull her a line, but this will give the mount a chance to correct, and it'll sync to it. Now let's start our live stack and clear it. Okay. In the meantime, let's go back over to Starry Night Pro and let's see if we can read a little bit about M63. It's a barred spiral, commonly called the Sunflower Galaxy. In binoculars, its soft glow is readily apparent, with nearby M94 visible in the same field of view. Rats, we didn't try to do that. Try to get M94 in the same field of view, did we? Telescope reveals a bright star-like core surrounded by a fainter halo. A hint of structure and spiral arms may be glimpsed with a larger instrument and dark skies, which we don't have tonight. But the arms will remain patchy and faint. The Sunflower Galaxy forms a physical group with the Whirlpool Galaxy, M51, and several other smaller galaxies, with the first original discovery of Charles Messier's friend, Pierre Méchain. And he went on to discover more than 25 of the objects in the Messier catalog. So that's pretty cool. So let's see. Can I grab this bar with my finger? No. Mouse is worthless, but see if we can. Looks like there is something right there in the middle, but not showing up as a. Oh yeah, there it's just starting to form in the moonlight. This moon, I wonder what percentage we are tonight. Let's find out what the percentage of the moon is. Looks like 89%. Wow, we must be nuts. 89% moon. But you know, you gotta just take the good with the bad, don't you? Let's try to move. Oh, this mouse Don't ever clean your mouse with Purell. Trying to bring up the mids now a little bit. Boy, I am not seeing a lot of M63 there. If it's there, it's just lost in that moonlight so far. The other thing we've introduced tonight is this, what you might call a rig rack. It's kind of off to the side. I wonder if I can grab that and bring it a little bit farther over. Yeah, there you go. If you look way far over the side, you can see a rack that's there now, and it has everything mounted. I'll have to do a little video on it later. I just got it done like moments before we started, but it's got shelves in it, you know, and all of our gear out there, like the Rig Runner and the Icron, what they call the Rex, which is the remote extender box. That's out there. It's got the power supply in it. All that stuff is in that grid. It's in a Gator grid that's portable. I'm really liking that. Okay, back to our M63. I wonder if we zoom in a little bit, if we'll be able to see something. Boy, our moon is not being kind to us. What I'm using is the upper right-hand corner. Yeah, there it is. There's the core of it anyway. The upper right-hand corner I'm using of the mouse pad because the middle just doesn't respond at all. Look at the way the moonlight's boosting up the blues. Now, look at that. You can start to see the sunflower galaxy forming up in that haunting blue light. Look at that. Let's see if we can get our mouse to bring it over a little bit. What weird light, right? With the moon there. But you can definitely see the structure starting to form, can't you? Now that's kind of yellow-greenish. I'm going to bring the green down a little bit. Boy, if you bring it down too much, look at that moonlight. What a crazy night for color balancing. If you use the zoom feature checkbox in the upper left of the histogram, you can get better control of your sliders. Yes, but my problem is the mouse is non-responsive. What are my options here? You know, if I had a corded mouse, I could plug it in and use the old-fashioned kind of mouse. I wonder if I have a mouse over there in a box, because this is not the entire middle of this mouse. Take a look at that image for a minute. I'm going to go see if I can find a real mouse. Where would this be? Mouse, where are you? Boy. You know, when you're trying to get rid of mice, they're just everywhere. When you're trying to get rid of mice, they're everywhere. And then when you want them, you can't get them back. Isn't that crazy? We're 7 minutes on this. So what I'm trying to do is use the upper left and the upper right where I didn't clean I'm just up in the upper left and the upper right corner. And I'm going to give this a little more green. And I think that's probably enough blue. But actually that's starting to look like M63, isn't it? With the moon right there beside it, I think that's the best we're going to do. That's probably not worth a picture tonight, but at least you can see it is a face-on. It's kind of at an angle though, isn't it? So now let's go back over to Starry Night Pro, and let me go up here to observe, and actually I think I have a session. If I just go here and say new observation, yeah, EAA on a cold winter night. I'm going to choose the 2600. I'm going to say, wow, the moonlight made this look eerie. Is that the way you spell eerie? The color balance was odd, but we could still make out the face-on structure. Okay. All right, let's head to M64. Before we do that, we'll say, oh, that's not a bad, that's looking better now, isn't it? I guess we'll save that just because it's there. Save exactly as seen. I'm using my fingertip. Then we'll stop the live stack. And on our sequencer, we'll say run recent next target. And then let's go back to Starry Night Pro and let's try M64. Let's see. M64. Oh, yeah, we're not hooked to our telescope now, are we? Because we had to exit out. So connect. And why don't we follow scope for a minute and get rid of the horizon, which I obviously have mounted too high. And let's go to M64 now. Slew to M64. So I need to get me a manual mouse for sure. This is no fun. Upper right. Jeff Horn, welcome. Good to have you here, Jeff. I've been sharing with the folks that I tried to clean my trackpad with this hand cleaner, and it did not work. Germex. I think it actually germed up the trackpad. So now we're at M64 in our planetarium software. Let's take a look at what it is. It's another galaxy, and let's back off and find the moon again. There's the moon. So we're still in that part of the sky. Wow, that's going to be another toughie. But I kind of like to see what our equipment is capable of. So let's go ahead and do this. There's our scope, and you can see it is aimed right at the moon. So there's the moon, and we're just right at it. And I shared with the folks before, that's the building I'm in, and I'm in that office there that's got the window light at it. So let's try this just so we can see what our equipment's capable of doing. I think it's always nice to try this. Let's change that name to M64. And let's go ahead and back down to auto and do a plate solve. So we make sure we're at the, I kind of think I might see it there in the middle. Boy, that sky is bright, isn't it? This is the 2600. Thanks, Jeff, for that encouragement. That's that That's that ASI 178 that's viewing the atrium there. So you can see where we are. We'll bring the view of the scope back around. This is a good view of being able to see the dew shield on the front of the white tube, the optical tube assembly, and then on the top of the scope, you can also make out that little outrigger that I have with the Losmandy adapter and the Losmandy equipment plate there. You can see, you know, the Pegasus, the Pegasus Astro Pocket Powerbox Micro, and you can also make out the Pegasus Astro USB control hub. You can see both of those there up on that outrigger on top of the white tube. And that little black shadowy thing past the tripod, that's my truck in the background. Let's now go to the sequencer and switch to start imaging. And it'll change the exposure from like 3 seconds to 20 seconds and change the gain from 400 to 100. And we'll close that sequencer now and clear out the last live stack. And there we go. Moonlight coming in. Let's go back over to Starry Night Pro for a second. And I'm having to do these with my finger. This is just no good. Let's get those minimized too. Boy. M64. Let's show info. And now we'll go back to the view in the moonlit night. The black-eyed galaxy is named for the prominent dark lane near its center. The dark lane is a dust cloud which hides the background stars and is itself an area of active star formation. The dark lane may not be really obvious through a telescope. A combination of dark skies and high magnification is needed to detect it. Locate the soft glow of M64 binoculars before taking a closer look with a telescope. Okay, I'm going to see if I can use the top corner of my mouse pad. Boy, not very well. And move that over there, and then I'm going to grab the mids and move them over here. Kind of have to make allowances for the moon, don't we? I'm gonna back those mids off just a little bit because you see so much of the moon's halo there. There we're starting to see the M64 form up there. Look at that. You can see that black eye underneath it, even in the moonlight, can't you? Let's give it just a little bit of blue. I'm going to see if I can find a portion of my trackpad that still works. How long will it take? Gave it too much blue. How long will it take this trackpad to be back to reality? That's the question. Look at that dark lane underneath there that gives it that black eye. Now you can see why they call it the black-eyed galaxy. Boy, if you just give it even a touch of blue, it goes completely crazy with the effects of that moonlight. But isn't that cool? You can see, can you make it out? Right there. See that black dust lane right underneath the core of the galaxy, which does give it its name. And then I wonder what these stars are. Let's go back to Starry Night Pro Plus. That's not a famous star. These are just Tycho Tycho numbers of these stars. Let's go ahead and do a new observation and say moonlight suddenly is super blue, but we could make out the black eye within a couple of minutes of imaging. EAA is amazing. But you know, we are going to look forward to getting away from this moon, aren't we? Mike. Is that the Mike that I know? I think that's Mike without an L. And if you're the Mike I'm thinking, you play a mean attacking mid. Is that you, Mike? That's really cool that you stopped in to say hi here. And yeah, you're right. Papa Tech is there in South Florida. Let's go back and see what our live stack looks like now. Yeah, there you go. After 5 minutes, you can make out that black eye definitely below. And with the moon right there, I think that's the best we're going to get. So we're going to save this as seen. I don't like this mouse. I've lost all control of the mouse. I need a new mouse, gang. I think this is gonna definitely be a good cause for a new laptop, don't you think? What could I do? Anybody have a hunch? Let's put this back on auto and take our sequencer back to next target. Do you have any eyeglass cleaner or wipes handy to try and clean the trackpad? Sometimes a damp cloth works. Okay, I'm going to try it. Let's see. I have a Kleenex, but I don't think I have any eyeglass cleaner. Rats, I wish I did. No eyeglass cleaner. Now, if I rub on this mouse, is that going to like destroy something? I'm going to get this tissue a little bit wet. Hold up your mouse, Doug. What kind? It's the trackpad. It's the one built into the laptop. Okay, so it's a little bit damp. And now I'm going to wipe it off. Okay, I don't know what I destroyed there, but who knows what I... Simon is doing tech support on my mouse. Okay, it's not back yet, but maybe it just needs... Oh my goodness. Did I just close? No, there it is. Okay. Who knew that we could have an 11-inch telescope set up out there and it could be working great, and our trackpad? Wash your hands too, as you may have residual on your fingers. Wow. So I could use the hand cleaner to wash my hands? Or the water, you're thinking? Wipe my hands off in the water? That's a good idea. Okay, I'm going to try that. Blow dryer. Mike. Yep, looks like could have some time tomorrow and Sunday. Mike is quite a soccer fanatic. Chelsea is his favorite team. He even has Chelsea seat covers on in his car. I don't know what his favorite kind of telescope is, but I know what his seat covers are like. No mouse yet. All right, back to the next target. We're gonna learn how to do a mouse before it's over. Okay, it's M65, and we're gonna slew to M65 blindly. So let's go back to the telescope view, and let's also look at this. So we're looking at the 178. Boy, it looks like that is like straight into the moon again. But that's okay. The moon's not going to scare us off, is it? Let's go back to here and say, was it M68, right? M65. Okay, M65. Boy, without a touchpad, we would have been dead in the water. Let's do one more plate solve. Just to, you know what? I think I see two objects there. Can you make them out? They're just barely visible there in the moonlight. Oh, now we're just 4/100ths of a degree off. So our model's looking pretty good for this part of the sky now. So now we'll do sequencer, run recent, start imaging. And then while that's imaging, let's go back to our planetarium software and let's look at the info for M65. M65 and M66 are separated by a mere 21 arc minutes. Both can be observed in the same low magnification field of view along with NGC 3628. What is NGC 3628? Ah, look. So this is like a trio of galaxies. Are we in Leo? Is this the Leo Triplet, as they say? Together, these three galaxies make up the Leo Triplet. I should have kept on reading the next sentence. NGC 3628 is larger but fainter than the other two, with a prominent dust lane running across its length. Yeah, Jeff Rhett, welcome. Good to have you here. Rhett, I don't know where you're coming in from. Anyway, the sight of this lovely trio is a delight under low power, and telescopes. M65 is quite large and oval-shaped. M66 has a noticeably bright star-like nucleus. A moderate aperture telescope begins to reveal subtle detail. So let's get these straight. It should be hamburger is my favorite in that. Okay, so the hamburger is NGC 3628, right? So the hamburger is on the left at a 45-degree angle, and that's NGC 3628. And then M65 is on the upper right, and 66 is on the lower right. So let's go see if we can find those now. First, let's just look here and see if we can find Leo. Yep. I don't think I can point at it. There. This is the back triangle of the Leo, see? So let's go back over to our planetarium software. And let's see that triangle? That is the back of Leo. So as we look at that triangle, this is where we're going to be looking, just off to the right of the longer leg of the triangle. Now let's go back to our 178. Yeah, look, the moon is here and our galaxy is right here. So we are just probably 10 degrees off from the moon. What do you think that is, an airplane? It's not a satellite, is it? That's probably it's probably an airplane, isn't it? Yeah. Let's go back over here now and close that thing. Let's see what we got here. Let's zoom into about 25% for starters. this out of our way. Now, is this the galaxy on the lower right? That M65? And is that 66? And then the hamburger should be over here somewhere? Because I'm not seeing it. This is just 3 minutes. I don't know if we can tune this up any better or not. Yeah, that did help, didn't it? But boy, if we bump those mids up any more, I think I'm beginning to see the hamburger. I think the hamburger is right here. If we had a mouse, I'd mouse it in the morning. I'd mouse it in the evening. Now right here, I should be able to grab that and bring that up to the middle. That's actually not bad framing, but let's see what happens at 33%. I don't think we can go any closer, can we? 40? Actually, that's pretty good, isn't it? Okay, so this upper right one is M65. So it goes 65, 66, 36, 28. Okay, let's go back. So M65. Wow, you can start to see some arms. M66. Wow, look at the material you're starting to see thrown off there. And then 3628, you can see the hamburger as a part of that structure. Let's go in a little closer. And let's get our information screen off of our look at that. If you would have told me that we were within 10 degrees of the moon and that we were able to see all that material being thrown off that galaxy, I would have thought that you were crazy. But sure enough, we can, can't we? The magic of electronically assisted astronomy combined with the open aperture of the RASA 11 f2.2, I think it is, with that field of view that it has, just a very wide open aperture, drinking in this light from this galaxy, it still amazes me that it can be tunnel vision right there beside the moon. That's just nothing short of, to me, it's just remarkable. Let's go up now and look at, so this is 65 at the top. And then let's go down and find that hamburger, since Jeff said that was his favorite part. Whoop, I touched the... Now, the reason they call this hamburger, obviously, is because the meat is making the black stripe that we're seeing in the middle of it. So in this haunting moonlight, can you make out the two flat buns? It's kind of more like on flatbread tonight. And that black is actually a dust lane there. So pretty remarkable. Let's go ahead and save this at 8 minutes. If we had a mouse capable of actually moving. And then let's back off just one more time so we get one last view of it at 40%. Oh, it looks like a satellite moved across the frame there, huh? There we go. The Leo Triplet. How about that? Okay, so let's do our observation of this. So we can do 65, 66. Wow, just 10 degrees or less from the moon. Yet we could still make out structure on all three objects of the Leo Triplet. This M65 upper right. And then what we can do is go here and could make out material being thrown out into stellar space. Leo Triplet. And then for this NGC 3628, we'll NGC 3628 NGC 3628 This is the first time I've ever experienced a completely deformed mouse. The middle of this trackpad is still absolutely worthless. I wonder if I've ruined it forever, or is this just a malformity that's going to last? Oh my goodness. Cancel. Oh, we're here. New observation. Third member of the Leo Triplet. We could clearly see the hamburger meat in spite of the moonlight. Boy, am I glad to be done with these. This moonlight is crazy. Let's go find M66. Oh, we were just there. Sorry. M67. Says it's at 57 degrees. Oh, good. Maybe this will mean that we'll slew away from the moon a bit, which we wouldn't mind a bit, would we? So you can see when the scope moves now, it's weights up. See those counterweights over on the right. If you look at the lower right hand, that's not a picture of the scope. That's a live video of the scope. By the way, to keep the WISE 3 from freezing and becoming useless, what is that over on the right in the scope view? It must be an airplane, huh? To keep the WISE 3 from freezing up and becoming, there it goes across the 178's field of view. We actually have a pipe wrap plugged in, and we brought that pipe wrap, and that little snake-like thing that you see strung in front of the tripod in the live telescope picture is that water pipe tape to keep water pipe from freezing, and it's strung over around the WISE 3 just to keep a little bit of heat on the WISE 3 because it's been freezing out. If you get below, really, if you get below 17 or 16 degrees, it is worthless. It's cool to see the, I guess that's an airplane, right? Okay, so let's go over to SharpCap and do our sequencer. Start imaging again. And it should clear, I think it clears the live stack for us. And remind me, was this M67? Yeah, M67. Boy, I love this newer version of SharpCap that lets you put the title of the object in after you've started live stacking, and then lets you change the name. Isn't that awesome? So we're going to close. Oh yeah, it's a nice little cluster. Look at this. It's beautiful, isn't it? Let's go back to auto here. Look at that. That's at 16%. There's full screen. Nice little multicolored. I don't know if you can see the yellows. Boy, now that we're away from the moon, we have a more realistic looking color balance. Look at that. Now that we're away from the moon, look how our peaks actually line up. We can bring our darks over to a realistic place. And then maybe it'll bring up some of the star colors when we bring our mids over. Tonight I'm in a different spot out there in the grass because I want to see if we can get to the place where M30 will be at the end of the Messier Marathon. So in other words, at 6:30 a.m., we will have to try to find M30 as the last target, just right at sunrise. And in case it does rely on Emerald Hills here, I want to see if we can get to that view from the place where I've set up the scope tonight. And once again, the place where I've set up the scope is out in the grass, actually. So it's not in the place where the observatory is going to be. It's out in the grass in a little bit different spot, so we can try to see around the building. And we'll know later if we can get to that. Okay, let's go over to look at M67 here. And let's look at the info. Did not pick M67's info. M67, there we go. 5 billion year old M67 is one of the most ancient open clusters known. It is a bright cluster containing more than 500 stars, many of which are resolvable with binoculars, including a couple of prominent 8th magnitude stars and about 50 9th to 12th magnitude. Let's move this information box off of the center and go back at the live view. So you're looking at the live view of M67, and then we'll keep reading here. It's spread out over a 25 arc minute area. You know how the sky is divided up into degrees. For those of you that are still new to astronomy, the sky is divided up into 180 degrees that you can see in any one half, and then each degree is divided into 60 minutes. So this says it's 25 arc minutes. So about half of a degree of the night sky. And that's a pretty small, pretty tiny slice. To appreciate the cluster's magnificence, a moderate-sized telescope is required as it brings in the fainter members. So let's go into about 40%. We're seeing a lot of salt and pepper kind of fainter members here. It's beautiful, isn't it? Let's say lots of salt. this is one of those times that I've told the folks at Starry Night, SimCur, Simulation Curriculum, about. See, lots of, let's go back to let us see the live view while we're logging here. Lots of salt and pepper stars, all different colors, strewn across these 25 arc minutes. What I was going to tell you is sometimes Starry Night Pro's observing note field only gives you just a handful of characters, and then it freezes there. It doesn't freeze, but it won't accept any more characters. It's like the max characters. So it's just a glitch in the software, and I've reported it. So we'll see if they address it someday. Well, that's a pretty good view, I guess, of in a moonlight night of M67. So there we go, saving a view exactly as seen. And we'll switch our sequencer to the next target. Jeff says, of course it's clear here tonight. Both weather apps said poor conditions, so didn't set up. And then he laughed. Sorry about that, Jeff. You know, the one that has been scoring for me is that, what's it called? Clear outside. And it has nailed the last few perfectly, just exactly as I would have hoped. So having pretty good luck with that clear outside. Okay, we're over to M74 now. It's supposed to be at 11 degrees. Let's see if we can do it. Slew to M74. This word slew is just another word for move. It's just a word that's used to describe when you're moving the telescope. And we have our planetarium software set so it follows the movement of the scope. So wherever the scope point, you can see the crosshairs over to the left, and then that field of view indicator is chasing those crosshairs. The WISE 3 surveillance camera that's viewing the telescope live, it's looking pretty much down the rifle barrel of the scope when it's pointed at Polaris. So what that tells you is that what we just did is we aimed over toward the west, because now the scope is pointing to the left. And that's, sure enough, that's your left, so it's west. Like I say, back here in the back, that's my truck. And this here is that new rack, the Gator rack that has all that equipment in it now. And boy, I'm loving that rack, yes. Let's go back over to SharpCap now. Where are you, SharpCap? Here's the live sky view. You can see here a nice view of what we're calling, it's one of our prayer shelters. Really, they're just like gazebos that we've dedicated to prayer. And we have 29 of those on our property. So that's kind of a fun view of it there in the moonlight. M74 is setting fast. Whoops, we better get there. I bet we've already lost it in the trees then. Let's go ahead and switch over to... Oh, you're right. Look at the trees. Yeah. Can you see the movement of the scope? And then, I don't know if you can make out the trees there. But sure enough, it is in those trees. So what was the height of this? M74 was at 10 degrees. By the way, while we're there, while we're in that planetarium software, let's bring that horizon back up. Yeah, look. That's actually... Oh, no. I've got it way too high, don't I? Look at that. So that's where 10 degrees should be, right there. Look at that. Yeah, so we're seeing, that's the galaxy that we would see face on if it weren't lost in the trees. So I've got it too high. Quite a bit too high. Tell you what I'm going to do. I'm going to just quickly see. View. No, view. Okay, that's one way to close it, right? I'm going to edit that program. I'm going to edit that file that sets the height and see if I can get a little bit closer. So that is located on C in having to use the upper corners of my mouse pad under users, right, app data, local. Now I'm using the touch screen to scroll it with my fingers on the screen. And then SimCur, simulation curriculum. And then Starry Night 8 prefs. And then sky data. And then horizon panoramas. And it's true, they don't provide that in the documentation, sadly. Okay, so we've got our height set on 30. Let's lower that to about 10. And, oh my goodness. When I grow up, I'm going to have a nice mouse. Now we're going to open up Starry Night Pro Plus again. And we're going to go find M74. And see what our horizon looks like now. Let's zoom in. Much better. That's a little more realistic because it was lost in those very trees. Okay, I'm happy with that. So let's connect our scope. It's under view. Oh my goodness. Lord, please forgive me for wanting to clean my mouse pad with Germex. Show telescope setup. Connect. Did we get it? Yeah, we got it connected. That won't close. Hello. Well, it's just not closing, is it? Okay, it finally closed. Oh yeah, I closed all right, didn't it? Boy, that telescope control. I know what you guys are going to say. You're going to say, Doug, that is the third time. Ah, there we go. Okay. Messier objects. And let's go back over to our trees where we have M74 lost. And let's see what is next. Look, we have a whole different, there was M74. There we go. So this is in numerical order again. Okay, so M74 is at 9 degrees. Let's try M76. Okay. And you can see the crosshairs over to the left. And there's the scope slewing to it. Now let's go back over to Sharp Cap, and under scope control, which is Control T, let's say follow scope. And zoom in there. So again, this is M76. Oh, this is the little dumbbell, right? Okay, so let's go over to our camera, and let's say, let's do a plate solve real quick, just since we can. And this is a different part of the sky, so we'll add this to our mount's computer memory of where everything is. Mr. Nother, good to have you here. Past 6 a.m. from Germany. Thanks for checking in. So there you can see it kind of lining up. We're at 40%, so let's back up to auto so we can see the whole sky. Auto, there we go. That's better. So we were 0.13 degrees off because this is the first time that we've done a sync in this part of the sky. So that way we'll add this to the mount's computer model and we'll be on track next time. So let's change the name to M76, right? Yeah. And in our sequencer, let's go to Start Imaging. And what that'll do, like I've said, is it automatically changes the time of the exposure to 20 seconds, and it changes the gain to 100. So that way we can be looking at something dim. And then it also starts the live stacking and clears it for us. It does a lot of things in one fell swoop. So we'll let that do a couple of frames. While it is, let's go here to the planetarium software and let's look at show info. By the way, Mr. Nother, in case you're tuning in, missed the first part, I actually cleaned my mouse pad in a well-meaning way with Germex, and when it did, it completely disabled it. So I haven't been able to use the mouse correctly since. I'm having to use the touch screen. The little dumbbell is a favorite object amongst observers, and it resembles its larger and brighter brother, the dumbbell nebula M27. A small telescope will reveal this planetary nebula's direct or distinct hourglass shape. M76 is perhaps, let me put this over here, and let's go look at the actual live sky there to the left. Perhaps the faintest Messier object. How about that? M76 is perhaps the faintest Messier object. However, its light is distributed over a small area, which means it can take high magnification quite well. Averted vision will help you see its two distinct lobes. Now with EAA, you don't have to use averted vision. Averted vision is when you're looking through an eyepiece and you aim your eyes off to the side and you use your peripheral vision to observe the object. Take some practice. But with electronically assisted astronomy, you don't have to do that because we're just looking at a screen and we don't need averted vision. It helps you see two distinct lobes and nebulous wisps. The little dumbbell was once thought to be two different objects, and still has two NGC numbers. Now, I didn't know that. NGC 650 and NGC 651. Okay, so let's do some adjusting here. Since we're at a different part of the sky, let's do an attempt at auto color balance, and it was not very successful. Look how high it put the reds. You know, with a 89% moon, I'm noticing that with a Rasa, at least with this Celestron light pollution filter that I'm running, you really have to dial down the blues when there's this much moonlight. Now let's go over here and grab this black level and bring it over here just to the right of those peaks. And then let's don't push the mids quite that much. Okay, now let's zoom into 100%. Oh my goodness, we got a focus issue. Look at that. So, tell you what, let's do, because we are not going to be able to see this object very well till we focus. I'd say the temperature has changed. Let's go look at the temperature. Oh, 10 degrees. It's about a, 2-degree change. But I did have guys tell me the other night, when the temperature shifts 2 degrees, that their rig will automatically refocus. Mr. Another, oh, poor mousepad. Yes, I missed it. It's Saturday morning and there's normally no reason getting up so early, but I will go on a short trip with my daughter today. Mike, Jerry, good to have you here. Donuts. We did this for you, Mike. Free donuts for you on Saturday morning. How about that? Okay, tell you what we're going to do. We're going to stop the live stack. We're going to pull out of the 2600. We're going to close both. No, I don't think we have to close the other sharp cap. We're going to open up Nina and load that profile. We're going to load this camera and go to the focuser and load the focuser. We're going to go to imaging, start autofocus. Now, will it autofocus correctly with the little dumbbell in the middle of the picture? Here's my theory. I think it will. Because why? Because it's comparing, not reading absolute half flux radius on stars. And if you're familiar with NINA, it's night sky and nighttime imaging and astronomy. NINA. NINA. It's an astrophotography program, to be honest. But it does have a nice autofocus routine built in. And the way the autofocus routine the way it works, in case you're new to astronomy, I know most of you guys are seasoned here, at least that are speaking up. But if you're just kind of lurking there and you haven't spoken up, we'll at least do the 30-second explanation on this. What you're seeing here, let me get rid of this. What you're seeing here is that the NINA software uses our telescope's camera to snap a couple of pictures of the night sky, and then it moves the focuser a little bit farther out to the right, which might mean that the mirror is moving farther back, let's say. Snaps a couple of other pictures and compares them. Moves it a little bit farther right, which might mean the mirror is a little farther back in the tube. Snaps a couple more. All the while, it's comparing the half flux radius of the star. Now, what is the half flux radius? It's a measurement of the luminance of the star as determined by 1/2 of its radius. and it measures basically the flux and compares it with the next focuser position. And if the flux is wider, if the half flux radius has grown and the star is a little wider and therefore kind of it's a bigger deal now, then the focuser, Nina makes a record of that and it hypothesizes, okay, I think I'm going the wrong way. And it goes out like 5 positions the wrong way before it concludes, this is definitely the wrong way. Now, I have Nina set so it uses multiple stars in the middle of the picture, but not just in the center. So I have it set to use all around the center, but not only in the center. And then I don't have it using the outside. And that's because before winter came, I got my camera pretty dialed in, but I could do a little better on the back focus on my camera and the Octopi Astro interface I have for my camera. So I didn't want to mess with the outside stars in case they were going to throw off the focus a little bit. I just wanted to do the inner half of the picture. And with Nina, you can dial that in pretty well. So it's really focusing on the middle of the picture, and we're going to see if it does okay with that little dumbbell right there in the middle of this picture. We're going to see how much that messes it up. It's a good research project. Mr. Nether, yes, we did find a way to use the WISE 3 surveillance camera. We went into the settings of the WISE 3 app, and believe it or not, there is a place in the settings that you turn off the infrared. And I loved it because using that, I could turn it on and turn it off, and turn it on and turn it off. And when I turn it on, that dew shield just picked up that glare that you guys helped me identify the other night, blindingly so. When I turned it off, it just like turning off the closet light. It just went black. And so the light that you see of the scope, let's see if I can bring it up here. The light that you see of the scope is all moonlight. There's not a single bit of infrared lighting up that telescope tonight. It's all starlight and moonlight that you see there. So it is very bright out there, isn't it? But I tell you what, even without moonlight, just with the night vision of the WISE 3, without infrared, it still picks up a shadow of the telescope, which I was really impressed. It still does okay, but the moonlight just looks like it's in the middle of a drama at the auditorium downtown, doesn't it? It's so bright because of that moonlight. Yeah, thanks, Mr. Nether. Mike, I'm sorry. I hope you picked up one of those donuts, because what Mike means is that when the telescope gets out of focus, the star shapes begin to look like little donut patterns because of the nature of the way. I'll tell you what it has to do with. It has to do with the fact that we have a central obstruction in our RASA, and the central obstruction is the camera. And so if you're out of focus at all, the central obstruction becomes a bigger deal. But when you're in focus, the telescope has so much good light that's coming to it that middle, even 20 or 30% of the middle of the telescope, it doesn't even need it. It has such good light coming in from all the edges. So any Newtonian or any Rasa, any Schmidt, all of those that put the central camera or the mirror in the middle, they'll all show donut shapes when it's out of focus. Now you're starting to see this pattern, aren't you? So what it did is it found a trend that the stars were getting bigger and bigger and bigger when it was going off to the right, which might mean moving the mirror farther back. So now it's going off to the left, and let's say in this case it's moving the mirror closer to the camera. And it's starting to hypothesize, look, this is starting to go out of focus. So I think position 29,949 is going to be the favorite spot. And you can see that's where the red dot is, 29,949. And in a moment, when it finally concludes that indeed it is way off of, the stars are getting bigger again, donut shaped again, in its auto-focusing of this motorized focus that's built in now that we added to the RASA, then it's going to conclude, okay, I've gotten the focus the best I can, and the best I could find was 29,948, I think it's going to be. We're going to see here in a minute, because it's very close to deciding, I can tell. And this curve is what you want to see. That's just beautiful to the eyes of a guy that wants to focus his scope. 29,943 was the decision that it made. And it uses that red line as the trend line. And then you can tell that in each of these focus positions, it took a couple of pictures. So we're going to take that. That's really exciting. We're going to go back to equipment now and look at the focuser and disconnect that. And look at the camera and disconnect that. And then we're going to close Nina altogether and open up SharpCap. Now you might say, well, why did you have to close SharpCap? It's that these programs will just grab control of things like the focuser or the camera. And unless we close them, unfortunately, oh, rats. I'm using my finger. There's the 2600. Okay, so now we're going to go right back. See, we didn't move the telescope at all. We're going to go right back to, well, it's already set on 20 seconds at a gain of 100. So we're ready to live stack. And those, do we have the, we don't have the target in here. M76, right? Live stack. Now, when we're live stacking, we're basically taking a picture and then taking another picture, and stacking them right on top of each other. And by doing that, the smart software is able to get rid of all this stuff you can see that is grainy. See all that looks like little sawdust and sand texture in the picture? It'll get rid of all that because of, boy, that mouse just does not work anymore. But if I go up in the corner, you know, I don't think I'm going to mess with the color balance. I think I'm just going to move this black level over a little and then move the mids out a little and come to the middle of the picture, and there's a little dumbbell. Now it is being impacted by that moonlight. Look at the way it's so grainy. Sad. But on a night with an 89% moon, I think the Spanish-speaking parts of our world have a phrase, a little idiom. It says, "Así es la vida, una lucha." And that's what we need to say tonight. Así es la vida, una lucha. It means roughly, oh, that's life. It's a struggle. The struggle is real. But you can still see the structure of this thing, can't you? I would say that the RASA at 100% would normally do better than this. But the moonlight is really disintegrating this image. Now it will get a little bit better as time goes on with these stacked photos. Oh, it says the stacking is paused. Sorry. There we go. You know, when I set up the scope out in the cold, I wear gloves, but even just, yeah, thanks, Frank. Even just the short amount of times I have to take off the gloves to like do keystrokes and stuff out there when it's 10 degrees, or I guess the feels like temperature would probably be 4 or something. Let's go find out what the feels like is. Let's see. Okay, this says 15 and the feels like is 9. So let's remember the feels like is about 6 degrees below the red temperature. So now let's go look at our actual temperature. 9. So if we go 6 degrees below that, if it's kind of parallel, that means it feels like 3 degrees out there. And when it's 3 degrees, I'm telling you, just a couple of minutes, my hands get so dry. And when I wake up the next morning, the ends of my fingers are cracked open. I know what you're going to say. You're going to say, oh, Doug, give it a break. But it's true. They just get cracked. Now, at least you can see the color in this little dumbbell, can't you? Can you see how it's starting to be? You know what we're going to do? We're going to actually go beyond the 100% just so we can see that color. See how it's starting to be reddish on the ends? Just with moonlight. You can make out the fact that it's dumbbell shaped, can't you? You are colder than me tonight, Doug. What are you out there? You're in Montana, right, Jeff? I think you're in Montana. Idaho, maybe. No, Montana. Drum roll, drum roll, drum roll. Instead of where in the world is Carmen Sandiego, it's where in the world is Jeff Horn. I think it's Montana. But there is a delay in the live stream, so it takes a while. You know what else we're into over there is the dome light of Louisville. So not only are we fighting the moonlight from our rear right shoulder, illuminating the entire sky, and look how bright the property is. You can just see that gazebo perfectly. But then we're also dealing with the 30 degrees in Montana and 3 degrees feels like temperature in Louisville. Not fair. Okay, so that's 4 minutes. And we're going to stop there just because. Boy. And this is M76. Let's go back to here. M76. And we're going to say new observation. Boy, between the dome of, between the light, yeah, this is one of those times. Simcur. New observation. Between the light dome of Louisville and the moon over our shoulder, this was a tough image to capture, but we could see the color and the lobes at least, but it stayed grainy at 4 minutes. I think that would straighten out a lot if we went out to like 11 or 12 minutes, but we're not gonna. Okay, let's go back over to SharpCap and stop the live stack. One last picture. You know, this blue, we need to go a little bit to the right to get rid of that blue. And then here, that's starting to look really cool, isn't it? Pretty cool for a moonlit night in the light dome. Mouse is worthless in the middle. Okay, save that one last time. And then stop the live stack. And in the sequencer say next target. And then let's go to M77 is at 7 degrees. I don't think we're going to be able to do that. M78. Let's salute M78. And we'll back off, way off, so we can see the crosshairs. And then we'll add the scope view. And again, the crosshairs move, and then the field of view chase the field of view rectangle, it chases the crosshairs. So M78 is right there in Orion's, just off of Orion's right stomach. Look at that. It's a unique diffuse nebula. Where are my donuts? Mike, you shouldn't have pointed them out because we went and focused. Papa Tech, grandsons have ice hockey game in the AM. Night all, enjoyed as usual. Papa Tech, thanks for joining us. We are so grateful that you stopped by and you stayed up late for that ice hockey game. You better go hit the sack. Look how we've got two different areas of this. And I guess M78 must be would you say M78 is this lower part right here? And then this must be something else. You think? Maybe not. Maybe the whole thing is M78 and then LBN 918 is perhaps the, tell you what, let's right click on this and let's say select other and see what else we got there. Well, there are 3 dark nebulae here, 918, 933, and 934. And also, is that SH, that's Sharpless, is that what that catalog is called? But LBN, I think that means, no, maybe that means something bright nebula. LBN, let's go look that up. That's going to bug me. Let's LBN wiki nebula. Lens bright nebulae. LBN. Lens bright nebulae. Now, the bright doesn't mean that it's actually blinding. Bright, it means as opposed to dark. So you've got dark nebulae and bright nebulae. So what this is telling us is we have several of these Lind bright nebulae, but we also have dark nebula between here. So we need to learn all these. Let's go over to SharpCap and let's see if we are in the right place. Boy, you can't tell by that, can you? Just doesn't look like anything there. Let's change our name to M78. And then in the sequencer, let's go to Start Imaging. And it'll take care of all those changes for us. And let's hope we're aligned clearly. Maybe the sequence doesn't reset, like clear the live stack. Maybe we have to clear it manually. Boy, there's not that much there, is there? Wonder if we're in the right place. Maybe up there in the upper right. Let's stop this for a second. Let's go back to next target for a minute. And let's, since we moved, let's do a plate solve just to make sure that in this part of the sky we're still good. The scope is set up on a hillside, and I worked hard to get it level, but I wonder if during the night if the feet can 0.16 degrees. That's quite a lot. In the realm of a RASA 11, that's quite a lot. So I'm glad we did this. I think as the night goes on that those feet are sinking into the ground a little bit, and probably it's just not quite level anymore. So that's probably what we're dealing with. Now let's go to start imaging. By the way, Mike Jerry is on tonight, and Mike was the one who helped us get started in understanding SharpCap's sequencer. So thanks, Mike, for that start. That happened on one of the EAA gatherings that we did. So thank you, Mike, for doing that. Upper one is NGC 2071. Oh, okay. Thanks for looking that up. And then Mike is telling us to adjust the histogram, black level too far to the right. Yeah, I also think we just weren't aligned correctly. As you saw, we were 1600ths off. Jeff's using Stellarium Web on PC and Sky Safari on iPhone. Okay, I wonder if we should try to do a little bit of a color alignment here again, since it's back in the moonlight. Yes, I miss Gary as well. Mike Jerry is saying he misses Gary Hawkins. We'll get Gary back in on some of our gatherings. I think you're right. Gary did. He tried to get me started on the sequencer too, and you know, I just didn't pursue it at that time. It wasn't until we got together on a EAA gathering and you showed us how it could work, Mike, that I began to realize I got to do this, you know. Okay, I wonder if I can use my finger on that dark. Nope. I was trying to use the touch screen. If I put my finger in the upper right of the mouse, then the mouse pad will work. Kind of. I mean, not really, but it's better than in the middle. This must be a small target. Let's go into about, yeah, we're starting to see some of it there. Wonder how big this is. Let's go back over. Yeah, Gary, is this okay to say this on the air, that Gary is not active on cloudy nights currently? And let's just leave it at that. And then I'll tell you off the air sometime, Frank. There's a story behind that. Okay. So there's that nebula starting to come in. Let's go look at the 178 for a minute. Yes, you're right. It was Actually, Jeff, I think it was photometry instead of spectroscopy. He got involved in photometry, and that was a factor indeed. But there's also an issue with his participation at Cloudy Nights. Now, I'm not going to say it on the air just in respect to him, but I'll tell you guys off the air sometime. You know, that part of the sky in the 178 looks okay. It's because the moon is behind our right shoulder. Look, you can see Orion. Are you guys able to make that out? Do I need to brighten that up some? Or are you able to see that? Let me brighten this up some in the 178. There. So see Orion on its side there? It's kind of fun, huh? Well, if that's where Orion is, we must be pointed. So the moon must be up here. So the moon's off to our left now. So let's look at the scope view for a second. Yeah, that's why, because the scope is pointed northwest. Yes, he's okay. There's nothing wrong with him. There you go. Mike just filled everybody in. Yeah, I won't repeat that on the YouTube in case. He's definitely okay. That's right, Frank. Okay, so we're back to there we go. Wow, it's a little bit bigger than we thought, isn't it? Yes, you're right. Gary and Mike both. Me too, Frank. Same here. You guys really helped a lot. Let's go over to Starry Night Pro Plus. Yeah, you know, this image, this is a patchy nebula, isn't it? Look how that looks kind of patchy. Let's bring up the that's odd, isn't it? Boy, I'm gonna once we're done, I'm gonna go find a somebody else's mouse here in the office. I'm gonna steal their mouse. I clicked on something else, didn't I? M78. That is just ridiculous. M78. It must have put a deposit on the trackpad. Some kind of deposit. So at least I know now. Don't ever do that again, especially before a live stream. Located above Orion's belt, M78 belongs to the same large cloud of gas and dust as the main Orion Nebula, M42. Has two companion nebulae, NGC 2067 and 2071. All three are reflection nebulae, and M78 is in fact the brightest reflection nebulae. It is visible in binoculars, but best seen through a telescope. Tell you what, let's go over here to SharpCap and let's try our. Can we do our? Where was that? Under Tools? What was it called? Deep Sky Annotation. Could not align. So for some reason, It's not aligning the last 6 frames. It's odd, isn't it? It's a tough target for sure. I always thought that this was a dimmer target than the little dumbbell. I think you're right. The surface brightness of M78 is mag 12. Real tough at 90% moonlight. That's great, Mike. Thanks for helping. Well, guys, tell you what, let's do. Let's say here we could see. Oh, that's a shame. Let's try this again. We could see M78, but it was a tough target. The guys pointed out how dim it is in 90% moonlight. Let's do one last thing. Let's go to M42 just to finish out. It's 2 minutes to 1, and we'll use this as our last target. Let's go back over here and stop the live stack. Put an M42. Okay, and then start imaging. 20 seconds. We'll do just a couple at 20. But you know, 20 is almost too much with M42 with a RASA 11. Look at that. That's 1 frame. It's wild, isn't it? Look at all the hydrogen. That's amazing. At 89% moonlight. It's just night and day difference, isn't it? Between M78 and M42. That's 2 frames. It just kind of restores your belief in astronomy to go back to M42, doesn't it? Just the Celestron light pollution filter, Simon. The one that's made for the RASA 11. It's an expensive filter. Look at all those filaments in just, in just 60 seconds. And we're not actually, you know what, I'm going to do a auto color balance. Wow, look at the reds. Now, you see at 20 seconds the way that middle trapezium, look how that just gets blown out. You cannot detect that there are 4 stars in that middle if you shoot at 20 seconds. Wow, look at that. Look at all those filaments. Look at all that information. Look at that. You know, the astrophotography guys show us all of this in real high resolution after they've imaged this for 3 hours. And I just can't get over the fact that with electronically assisted astronomy techniques, EAA, that we can see these beautiful images in 2 minutes and 20 seconds. Well, that's probably a good place to stop, guys. It is 1 a.m. for you guys, and I want to be sympathetic. Look how we're starting to pick up these other nebulae here, where these other open clusters are too. Let me back off to the full view. And let's do the What's it called again? Deep sky annotation. Did I hit it? I tried to use my finger. Deep sky annotation. Okay, so we got NGC 1975 on the far right. NGC 1977 is the nebula there. Next one. But I think it's combined with the open cluster too. Then you got Marian's Nebula and M43. And then as you move to the left, M42. And then over to the left of the main nebula, NGC 1980. And then as you go up there to the left, two smaller nebulae, IC 0428 and IC 0427. It's fun, huh? I like what you're doing with SharpCap, Robin. Well done. Okay, guys, that's where we'll leave it. Thanks a lot for spending a couple of hours with us here on the outskirts of Louisville, Kentucky. We once again give thanks to God for making beautiful objects like this so we can admire in the night sky. You guys always teach us something when we do these. And then one of the things I'm going to do when I hang up, I'm going to go look at the spot where M30 will supposedly be at the end of the Messier Marathon, so that in the case that we don't have clouds, and in case I can help with the Messier Marathon images, that I can try my best to grab M30 from this spot, I hope. We're going to find out if this spot will help us get it. Thanks a lot, and we'll look forward to seeing you guys again. Good night, Mike. Good night, Simon. Good night, Jeff. Good night, Mr. Another. Good night, Frank. And anybody else that hasn't said hello, good night to all of you. We appreciate you being there. Thank you, Jeff. It's an honor, and you guys make it fun by me being here. Okay, good night, and God bless.